These are what we call scalable power laws. The ratio of millionaires to half millionaires is the same as the ratio of centimillionaires to those who have 50 million. It's the same, or for book sales, it's the same. The ratio is sort of scale invariant. And take the stock market, 0.2% of companies represent more than half the capitalization, 0.2%. The arts, maybe 0.2% of authors have more than half the books sold or mentioned. Academic citations, same effect. The bulk of, most academics are hardly ever cited, and if you just get all the credit. You have 1 million scientific papers every year. Very few have any impact. Hard work will get you a nice car, a nice house, maybe a nice watch, and for you, a nice bicycle. But to have a private jet, a private island, all that, you need the same amount of hard work plus a lot of luck. So because there's some outcomes that can be much more explained by variance than by there have been a lot of theological discussions on randomness, whether something is truly random or whether it's perceived as such because you don't understand the logic of the sequence. And to me, it's a full problem. It's maybe something that we should discuss on weekends in theological seminaries, but not in the real world. Your computer, if you generate a random sequence on your computer, there's nothing random about it. It is deterministic. It's just that you don't know the algorithm, and the thing is designed to deliver some class of distribution. Okay, example is that of a pregnant woman walking down the street. For you and I, unless you happen to be
have some inside information.
Exactly, privy to some information. It's a random number generator, all right? It's 50-50, approximately 50-50. For her doctor, it's 100%, or if it's a male, you can see it's 100%. It's a female, it's like 95%. So it's not random. Likewise, when people ask me about a black swan, define the black swan. Is this a black swan or not? I tell them it depends on what you know. For the butcher, it's not going to be a black swan. For the turkey, it is. For those involved in hijacking the planes for September 11, there's nothing uncertain about the event. But for the rest of us, it was black swan. The way I work with it is epistemic. And there have been a lot of philosophical discussions on randomness that I skip. I sometimes was involved. At some point, like everyone, you start reading books, philosophical aspects of things. You go deeper in philosophy and then realize that it was really functionally blind alley. It was like there's no point going in that direction, at least in my own work, maybe for someone else. Because then you go back to theology, definition of God.
Okay.
And the definition of God is for whom nothing is random. Very few events in history has had, the small number of events have driven most of the consequences of historical dynamics, all right? Take Christianity, take Islam, take very few events. But you can look at it also in terms of natural catastrophes, like very few earthquakes represent the bulk of the impact of earthquakes. Probability distribution is a very Platonic object that allows you to summarize a bunch of things, but we can work with it mathematically because there are some properties that are sometimes universal. Like, for example, if you have sequences of independent random events. So for me, they're classes of probability distribution rather than specific probability distribution. And there's a classification, right? From at the top, there's something called forget about it, because distribution, you'll never know the attributes from observation of random data, to others that are easier to track. And effectively, there are three classes. At the top, there's something we call the power law class, where things are determined by the extremes. And at the bottom, things are determined by the middle. Because you can easily work with the first one that is determined by the center of the distribution. To give you an example, nothing can really impact the average when you have a lot of observation. So let's take your annual consumption. You're in Beirut, probably one of the best cities to eat. 365 days a year. Not a single day can change your annual consumption.
Our annual consumption.
By more than 3 divided by 365, by 1%. So not a single day. It doesn't have a cumulative effect. It's very small. So the extreme is interesting, but doesn't play a huge role. But if you take Extremistan, it's the exact opposite. Everything's determined by the extreme. Take the stock market. 0.2% of companies represent more than half the capitalization. 0.2%. The arts, maybe 0.2% of authors have more than half the books sold or mentioned. Academic citations, same effect. The bulk of, most academics are hardly ever cited, and a few just get all the credit. You have 1 million scientific papers every year. Very few have any impact. So Extremistan, you have a lot of unfairness. Luck plays a much bigger role. Skills play a role, okay, but it's sort of like I give the difference. In Extremistan, you need hard work will get you a nice car, a nice house, maybe a nice watch, and for you, a nice bicycle. But to have a private jet, a private island, all that, you need the same amount of hard work plus a lot of luck. So because there's some outcomes that can be much more explained by variance than by what we call the drift. So these are the two classes, but as I said, there's a third class in the middle.
Okay.
So that class in the middle is what we call the sub-exponential class. It's more complicated. So let me define the three classes in terms of life expectancy. In Mediocristan, let's take aging, all right?
Okay.
As you get older, your life expectancy shortens. So conditional on being 0, your life expectancy is 80 years. But if you're 80 years old, your life expectancy is another 12.
Mm-hmm.
At 100, maybe 2.5 years. And at 120, a few minutes, right?
Mm-hmm. Mm-hmm.
So that is the first class. In Extremistan, for processes that are from Extremistan, the more something ages, the longer the life expectancy. Mm-hmm. Typically, so, or same thing, you can apply it to sales. The average sales of books of more than 1,000 copies are 2,000 copies. The average age of books that sold more than 1 million copies is 2 million copies. Mm-hmm. And the average life of something that survives 100 years
will be another
200 more years.
200
so
more
200 years or 100 more years,
mm-hmm.
however, it's
mm-hmm.
200 in total. So whereas in age, the average age of the person older than 80 is 92. The reason we die is a combination of accident and aging, senescence. So the accident part should never be neglected. So that part, the accident part, has a simple property. Let's say the life expectancy as a crocodile is 40 years. Okay. You observe a crocodile at birth, 40 years. Age 10, 40 more years. Age 40, 40 more years. Accidents are memoryless, mm-hmm. You see. It's like saying you just observed a natural calamity, not a hurricane because these are periodic, but the probability of having another one hasn't changed, you see. Sometimes it has increased. So sort of your light bulb, if it has 5,000 hours and you bought it 5,000 hours ago, it still has 5,000 hours. So that's in the middle. That's interesting for processes, that middle thing, interesting for many things, but not for risk management in the sense of the demarcation between Extremistan and Mediocristan, mm-hmm. the intermediate class. And you rarely observe it outside of hazard ratio and stuff like that. It's a distribution of accidents. We call the memoryless distribution. Fat-tailed is Extremistan. Okay. It's a distribution where you're going to have most of the impact coming from the smallest number of observations. So, mm-hmm. As I was saying, 0.2% of companies have more than half the capitalization historically, all right? It can even be even worse. You're taken cumulatively, mm-hmm. Mm-hmm. Can even be worse in some industries, such as technology. We worked, my colleagues and I, on modeling pandemics and wars. And these have the fattest tail. The smallest number of wars has killed the largest amount of people. A few wars have killed the bulk of the people who ever died in war. And the two of them we know, and there have been a few in the past, in China. And the same thing for pandemics. A very small number of pandemics have killed, or germs have killed the bulk. You participate to the bulk. The example I give about the spread of diseases is if you follow the Silk Road, and then the disease hitting Istanbul would take 2 or 3 centuries in case it's very, very contagious to reach areas in Northern Europe that were sort of isolated. That's what happened with the Black Plague. It reached Europe it took a while to reach Europe. It was slow. And there's some parts of Europe that were reached 3 centuries later. And the Americas, an infinite centuries later, never reached the Americas. The Americas was not in contact with the old world. So this is where you have to cut the transmission. The interesting thing about the extremistan is that these properties also apply to a lot of things in geometry, like fractal geometry, because there's self-similarity between the events. So in other words, to tell you why does it relate to scaling, these are what we call scalable power laws. The ratio of millionaires to half millionaires is the same as the ratio of centimillionaires to those who have 50 million. It's the same, or for book sales, it's the same. The ratio is sort of scale invariant. And you don't observe that in mediocre stan.